This is a recast of the 6,600-word piece, McCulloch-Pitts Neuron, from Schneppat AI. This article explores the McCulloch-Pitts neuron, a fundamental building block of artificial neural networks, its historical context, architecture, and limitations. It discusses the impact of the McCulloch-Pitts neuron on the field of artificial intelligence and its practical applications in various fields, such as medicine, finance, and information technology. Additionally, it highlights the strengths and limitations of the model and its implications for complex problem-solving. Let's listen in.
Today, we're diving into the fascinating world of neuroscience and artificial intelligence with a focus on the McCulloch-Pitts neuron. Developed in the 1940s by Warren McCulloch and Walter Pitts, this neuron is a fundamental building block of artificial neural networks.
That's right, Samantha. The McCulloch-Pitts neuron is known for its simplicity, yet ability to perform complex computations. Its structure consists of inputs, weights associated with each input, and an activation function. When the inputs are received, the neuron calculates the weighted sum of these inputs and applies the activation function to determine its output.
Absolutely, Theo. And this neuron plays a crucial role in modeling the behavior of biological neurons, revolutionizing the field of artificial intelligence. By simulating the functionalities of the human brain, artificial neural networks based on this concept have shown immense potential in various applications, such as pattern recognition, speech processing, and image processing.
The McCulloch-Pitts neuron, also known as a threshold logic unit, was a mathematical model of a biological neuron created by Warren McCulloch and Walter Pitts in 1943. This model laid the foundation for artificial neural networks and helped shape the field of artificial intelligence.
That's right, Theo. The McCulloch-Pitts neuron is based on a simple binary decision threshold. This means that a neuron either fires or does not fire based on the weighted inputs it receives from other neurons. The inputs are multiplied by their respective weights, and the sum of these weighted inputs is compared to a preset threshold value.
Exactly. If the sum exceeds the threshold, the neuron fires and represents the output of the neuron. On the other hand, if the sum is below the threshold, the neuron remains inactive. This binary decision-making process is a key characteristic of the McCulloch-Pitts neuron.
The significance and impact of the McCulloch-Pitts neuron on the field of artificial intelligence cannot be overstated. Warren McCulloch and Walter Pitts provided a simple mathematical model of a neuron, which laid the foundation for the development of neural networks and computational neuroscience.
Their neuron model provided a framework for understanding how individual neurons work and how they can be interconnected to perform complex computations. This model inspired subsequent research that led to the development of more sophisticated neural network models capable of learning and adapting.
Today, artificial neural networks are extensively used in various fields, such as pattern recognition, speech and image processing, and recommendation systems. The McCulloch-Pitts neuron brought attention to the idea that complex cognitive processes can emerge from the interactions of simple computational units.
Absolutely, Samantha. This notion has had a profound influence on the design of intelligent systems and has contributed to the advancement of artificial intelligence as a whole. The McCulloch-Pitts neuron showed that by combining simple threshold units, complex neural functions could be achieved.
Precisely, Theo. The McCulloch-Pitts neuron model significantly impacted the development of artificial intelligence. It provided a mathematical framework for modeling complex behaviors using simple computational units. Researchers were able to simulate various learning processes and understand how networks of interconnected neurons could learn and process information.
However, it's important to note that the McCulloch-Pitts neuron does have its limitations. For example, it cannot account for temporal dynamics or adjust its weights. But despite these limitations, its impact on the field of AI cannot be overstated.
That's right, Theo. Today, artificial neural networks have become an integral part of various applications, such as image recognition, natural language processing, and predictive modeling. The McCulloch-Pitts neuron paved the way for these advancements.
To fully understand the significance of the McCulloch-Pitts neuron, we need to explore its historical context. It was developed by Warren McCulloch and Walter Pitts in 1943, during a time when the field of neuroscience was just beginning to emerge.
Absolutely, Theo. The work of Santiago Ramon y Cajal, who demonstrated the cellular nature of the nervous system, and the development of computational machines provided a fertile ground for the ideas put forth by McCulloch and Pitts. Their neural model drew inspiration from the structure and functioning of the human brain.
This historical context emphasizes the innovative nature of the McCulloch-Pitts neuron and its contribution to the foundational understanding of neural networks.
Right, the McCulloch-Pitts neuron was a simplified representation of a biological neuron, utilizing mathematical logic and binary inputs. By assigning specific weights to each input, McCulloch and Pitts showed that complex logical operations could be performed by combining multiple binary inputs.
And let's not forget the concept of threshold functionality that they introduced. This concept allowed the neuron to generate a binary output, or firing, only when the sum of its inputs exceeded a specific threshold. This was a key component of their model and enabled them to simulate the behavior of real neurons.
Absolutely. And this groundbreaking work laid the foundation for further advancements in artificial neural networks. It inspired subsequent researchers to explore the potential of computational models based on the neurological principles of the human brain.
Absolutely. And as research progresses and more advanced models emerge, the McCulloch-Pitts neuron will continue to provide a solid foundation for the development of future intelligent systems.
Indeed, the potential for future advancements in the field of artificial neural networks is vast. Incorporating more biological realism, integrating cutting-edge technologies like deep learning and neuromorphic engineering, and exploring new types of network architectures and learning algorithms will all play a crucial role in pushing the boundaries of what can be achieved.
And with the rapid pace of technological advancements and the increasing availability of computational resources, we can expect exciting developments in solving complex real-world problems using artificial neural networks. The development of the McCulloch-Pitts neuron model was a significant milestone in the field of neuroscience and artificial intelligence. It marked a convergence between these two disciplines and opened up new avenues for research.
That's right. McCulloch and Pitts published their work in 1943, presenting a simplified model of a neuron that captured its essential properties and demonstrated how a network of these artificial neurons could perform complex computations.
The model consisted of a binary threshold unit that computed the sum of inputs and produced an output based on a predefined activation function. It was a simple yet powerful model that showcased the potential of neural networks.
Yes, and it didn't exist in isolation. The McCulloch-Pitts neuron model was heavily influenced by previous work in the field. Warren McCulloch himself was influenced by Santiago Ramon Hicajal's groundbreaking work on the structure of neurons.
Ramon Hicajal's research laid the foundation for our understanding of neurons and their functions. Another influential figure was Donald Hebb, whose work on neural networks and learning greatly influenced the development of the McCulloch-Pitts neuron model.
Exactly. Hebb proposed that neural networks learn through the strengthening or weakening of connections between neurons, a concept known as Hebbian learning. This idea was incorporated into the McCulloch-Pitts neuron model and helped shape its mathematical framework.
It's important to note that while the McCulloch-Pitts neuron model served as a fundamental concept in the field of neural networks and artificial intelligence, it does have its limitations.
That's right. One of the major drawbacks is its binary output, which can only represent two states firing or not firing. This limitation fails to capture the complexity and nuances of real-world phenomena that often require continuous values for accurate representation.
Additionally, the model lacks the ability to account for feedback mechanisms and inhibition, as it only focuses on the summation and thresholding of inputs. This prevents the model from accurately modeling certain biological processes and behaviors that heavily rely on feedback and inhibitory mechanisms.
And let's not forget that the McCulloch-Pitts neuron assumes equal importance for all inputs, disregarding any hierarchy or weightage. In real biological neural networks, certain synapses hold more significance than others.
Despite these limitations, the McCulloch-Pitts neuron model remains a crucial foundational concept in the field of neural networks. It paved the way for advancements and more sophisticated models that can address these limitations.
Absolutely. The work of Warren McCulloch and Walter Pitts laid the groundwork for further research in neural networks and artificial intelligence. Their model revolutionized the field and inspired countless researchers to explore the potential of computational models based on the principles of the human brain.
And as we continue to advance in our understanding of neural networks, we can build upon their foundational work to develop more complex and accurate models that can better simulate the intricate workings of the human brain.
That's right. So let's dive into the main points of the article. The McCulloch-Pitts neuron, also known as the binary threshold gate, is made up of three main components: dendrites, a cell body, and an axon. The dendrites receive signals from other neurons through specialized junctions called synapses.
These signals are typically electrical impulses and are then transmitted to the cell body, also known as the soma. The cell body integrates these signals to determine the neuron's output. If the total input exceeds a certain threshold, the neuron fires an action potential that is propagated along the axon.
That's right. The axon, which is commonly covered with a myelin sheath, allows for fast and efficient signal transmission. At the end of the axon, the neuron communicates with other neurons or effector cells through synapses.
And it's important to note that the strength of the signal transmitted by the McCulloch-Pitts neuron is usually binary. It's either firing or not firing. This binary nature of the signal allows for parallel processing within neural networks, enabling complex information processing and decision-making abilities of the brain.
Absolutely. Now let's talk about the components and architecture of the McCulloch-Pitts neuron in more detail. The inputs consist of a set of artificial neurons that receive either excitatory or inhibitory signals.
These inputs are represented by binary units and are passed through synapses, which are responsible for transmitting information from one artificial neuron to another. The outputs, on the other hand, are determined by a threshold value set by the user during the training phase.
This threshold value is used to determine whether the cumulative input received by a neuron is sufficient to trigger its activation. And it's this interconnectedness of artificial neurons, combined with the binary nature of the inputs and the defined threshold value, that allows the McCulloch-Pitts neuron to perform logical operations and make decisions based on the input it receives.
Moving on, let's discuss the input and output mechanisms of the McCulloch-Pitts neuron. In terms of inputs, this model neuron receives signals or stimuli from various sources, such as other neurons or external sensors, via its input connections.
These inputs can be either excitatory or inhibitory, depending on the specific weight associated with each connection. Excitatory inputs increase the overall activation level of the neuron, while inhibitory inputs decrease it.
And then the McCulloch-Pitts neuron processes all these inputs by calculating their weighted sum and comparing it to a predetermined threshold value. If the threshold is met or exceeded, the neuron fires and transmits an output signal. This output signal is binary in nature, representing either a firing or non-firing state.
Exactly. Understanding how the McCulloch-Pitts neuron processes and propagates information is crucial for comprehending its functioning and its role in artificial neural networks.
Right. The McCulloch-Pitts neuron processes information through its dendrites, where it receives signals from other neurons or sensory receptors. These signals are then integrated in the cell body, where the neuron decides whether to produce an output signal or not.
And this decision is influenced by the strength and frequency of the input signals, which are often mediated by excitatory and inhibitory connections. Once the decision is made, the output signal is transmitted through the axon of the neuron.
To propagate information, the neuron communicates with other neurons through chemical and electrical signals. At the synapse, which is the end of the axon, the neuron releases neurotransmitters that bind to receptors on the dendrites of the receiving neuron, thus transmitting the information from one neuron to another.
This process of information processing and propagation is essential for brain functioning and is the basis of neural networks and cognitive processes.
In conclusion, the McCulloch-Pitts neuron has played a crucial role in the development of artificial neural networks. Its simplicity and ability to capture the essence of biological neurons paved the way for further advancements in the field.
Although it had its limitations, such as the inability to learn or adapt, the McCulloch-Pitts neuron served as a starting point for researchers to explore more complex and sophisticated models.
Over time, modifications and improvements were made, leading to the development of more efficient algorithms and network structures. Today, neural networks have become a crucial tool in machine learning, artificial intelligence, and various other fields.
The McCulloch-Pitts neuron, although simple in design, has left a lasting impact on how we understand and model the human brain and has contributed significantly to the advancement of artificial intelligence.
Absolutely, Samantha. The McCulloch-Pitts neuron introduced the concept of thresholds and binary outputs, which paved the way for more complex neural network models. This discovery revolutionized our understanding of how the human brain functions and inspired the development of numerous applications in fields such as pattern recognition, speech synthesis, computer vision, and data analysis.
That's right. The ability of the McCulloch-Pitts neuron to process information in a binary fashion has proven to be invaluable in solving classification problems and aiding decision-making processes. Researchers have continued to build upon the foundation laid by the McCulloch-Pitts neuron, and its significance and applications will only continue to expand and shape the field of artificial intelligence.
Absolutely, Samantha. The McCulloch-Pitts neuron played a crucial role in the advancement of artificial neural networks. By introducing the concept of threshold activation, McCulloch and Pitts were able to simulate the behavior of real neurons. This laid the foundation for the development of more sophisticated models and algorithms.
Exactly, Theo. The McCulloch-Pitts neuron initiated the study of neural network architectures, learning algorithms, and pattern recognition techniques. It provided a framework for the construction of feed-forward and recurrent neural networks, which are widely used in various domains such as image and voice recognition, natural language processing, and predictive modeling.
And let's not forget about its impact on other areas of artificial intelligence, such as pattern recognition and robotics. The McCulloch-Pitts neuron provided a foundational understanding of how neural networks can be used to recognize and classify patterns. Its binary nature inspired the development of more complex pattern recognition algorithms that can process and analyze data at a larger scale.
Yes, and the concepts of weights and thresholds in the McCulloch-Pitts neuron laid the groundwork for the development of robotic systems. These concepts enabled machines to perceive and interpret sensory inputs, leading to advancements in robotics technology.
Absolutely, Samantha. The practical applications of the McCulloch-Pitts neuron model can be found in various fields such as medicine, finance, and information technology. In medicine, the model has been used for disease diagnosis and predicting patient outcomes. By inputting patient data into the neural network, the model can analyze patterns and identify potential diseases or conditions.
Similarly, in finance, the McCulloch-Pitts neuron has been utilized for stock market predictions, risk assessment, and fraud detection. Its ability to process and interpret large datasets allows for more accurate predictions and assessments in the financial realm.
And in the field of information technology, this neuron model has been employed in tasks like pattern recognition, image processing, and natural language processing. The ability to recognize patterns and make decisions based on the given information makes the McCulloch-Pitts neuron an effective tool in these areas.
Overall, the practical applications of the McCulloch-Pitts neuron model have proven to be valuable in various fields, contributing to advancements and improvements in medicine, finance, and information technology.
That's right, Samantha. And one of the key strengths of this model is its simplicity. It effectively captures the essential characteristics of real neurons without overwhelming complexity. This allows for easy implementation and understanding of the model in various computing systems.
Absolutely. And not only is it simple, the binary nature of the inputs and outputs also makes it easy to implement in hardware or simulate in software. This means that the McCulloch-Pitts neuron can be replicated and used in different types of computing systems without much difficulty.
That's a great point, Samantha. And another strength of the McCulloch-Pitts neuron is its ability to perform logical operations such as an OR and XOR. These logical operations are building blocks for more complex computations and make the neuron a powerful tool for solving basic computational tasks.
Definitely. And because of its fixed weights and threshold values, the neuron only requires a few numerical operations to produce an output. This efficient computation is another advantage of the McCulloch-Pitts neuron model.
However, it's important to note that the binary nature of the model also has its limitations. Real neurons operate on a continuous scale rather than a binary one, so the model overlooks this fact. This limits the model's capability to accurately represent more complex biological behaviors.
That's right, Theo. The fixed architecture of the model also restricts its adaptability. It is unable to learn from or adjust to new information. This means that it may not be suitable for tasks that require continuous learning or adaptation.
Absolutely. And these limitations lead us to discuss the oversimplification and inability to handle complex problems associated with the McCulloch-Pitts neuron model.
Right? Firstly, the model oversimplifies real-world neural processes by assuming that neurons are binary units, firing either a 0 or 1. In reality, neural signals involve a continuum of possibilities, resulting in a more nuanced representation of information processing.
Exactly. And this oversimplification may hinder its applicability to complex problems that require a more nuanced understanding. The model's binary nature may not be able to capture the intricacies and complexities of real-world phenomena.
And secondly, the model's inability to handle complex problems arises from its lack of capacity to represent higher-order interactions. These interactions often occur between multiple features or variables simultaneously, making it difficult for the model to accurately capture and process the intricate relationships.
Yes, Samantha. And this limitation means that the McCulloch-Pitts neuron model falls short in addressing the multidimensional and intricate challenges that complex problems present. It may not be suitable for tasks that require a deep understanding of complex patterns and relationships.
That's a great summary, Theo. Despite these limitations, it's important to note that the McCulloch-Pitts neuron remains a foundational model in the field of artificial intelligence. Its simplicity and computational power make it a valuable concept in neural networks and AI research.
Absolutely, Samantha. The McCulloch-Pitts neuron, with its binary inputs and outputs, is still widely used in various applications and continues to inspire further research and development in the field of artificial intelligence.
Well said, Theo, and with that, I think we've covered the main points of the article.
Indeed, the McCulloch-Pitts neuron has left a lasting legacy in the field of neural networks. It established a strong foundation for our understanding of these networks and opened doors for future developments in the field of artificial intelligence.
That's right, Theo. The concept of binary units, where the output is either on or off, and the idea that complex computations can be achieved through the interconnection of these simple units, continue to be fundamental principles in the field.
Absolutely. And as the field of machine learning continues to evolve, we can expect neural networks inspired by the McCulloch-Pitts neuron to play a crucial role in solving increasingly complex problems. These networks have already shown promise in various industries, including healthcare, finance, and entertainment.
That's true, Theo. Recent advancements in technology have allowed researchers to explore the use of more sophisticated models, such as deep neural networks. These networks are composed of multiple layers of interconnected units and have the potential to revolutionize various fields.
Exactly. Deep neural networks have surpassed the initial limitations of the McCulloch-Pitts model and are now key components of cutting-edge technologies. They have enabled significant advancements in image recognition, natural language processing, and autonomous driving, among other areas.
It's amazing how far we've come since the McCulloch-Pitts neuron. The simplicity and computational power of that early model laid the groundwork for all these advancements we see today.
Absolutely. But we can't forget that the McCulloch-Pitts neuron still has potential for future enhancements and applications. By incorporating more complex mathematical functions into the model, such as sigmoid or ReLU activation functions, we can capture more nuanced behaviors and simulate biological neurons with greater accuracy.
Yes, and it's also possible to introduce feedback loops within the network, allowing the model to learn from its own errors and improve over time. This has the potential to enhance the model's resilience and adaptability.
That's a great point, Samantha. And these enhancements can lead to applications beyond neuroscience and artificial intelligence. The McCulloch-Pitts neuron model can be used in various areas, including pattern recognition, signal processing, and optimization problems.
Absolutely. By leveraging the simplicity and efficiency of the original model while integrating these potential enhancements, the McCulloch-Pitts neuron has the possibility to unlock new frontiers in neuroscience, artificial intelligence, and other scientific disciplines.
It's exciting to think about what the future holds for this field. The legacy and impact of the McCulloch-Pitts neuron will undoubtedly continue to shape the way we think about and approach artificial intelligence.
Well said, Theo. We've covered a lot of ground today. Is there anything else you'd like to add?
Just that it's fascinating to see how far we've come from that simple model proposed by Warren McCulloch and Walter Pitts in the 1940s. Their work laid the foundation for subsequent advancements in artificial intelligence and continues to inspire researchers today.
Absolutely. And with that, I think we've covered all the main points of the article. Thank you all for listening.
But before we wrap up, let's take a moment to recap the significance and contributions of the McCulloch-Pitts neuron.
Good idea. So, to summarize, the McCulloch-Pitts neuron provided a fundamental framework for understanding information processing in the brain. By formalizing the structure and functioning of a neuron, their work laid the foundation for the development of artificial neural networks.
That's right. The concept of threshold activation, introduced by the McCulloch-Pitts neuron, has been widely utilized in machine learning algorithms to mimic the behavior of biological neurons. This model has played a crucial role in the field of deep learning, revolutionizing areas like computer vision and natural language processing.
And let's not forget that the McCulloch-Pitts neuron fostered a shift in focus from individual computation to the study of complex systems and emergent behavior. Their work highlighted the importance of connectivity and network structure in understanding neural networks.
Absolutely. This shift in focus paved the way for subsequent neural network models and propelled the field of artificial intelligence forward.
So in conclusion, the McCulloch-Pitts neuron model holds immense significance in the field of artificial intelligence and neural networks. It has provided a solid foundation for understanding how neurons work and has been instrumental in developing various applications, such as pattern recognition and machine learning.
That's right. And despite its simplicity, the McCulloch-Pitts neuron model continues to be relevant in contemporary artificial intelligence. Its fundamental principles have paved the way for more complex and sophisticated neural network structures.
Exactly. The concept of binary activation, inspired by the McCulloch-Pitts neuron, is extensively used in modern deep learning models like convolutional and recurrent neural networks.
And let's not forget about the importance of connectivity and network structure. The idea of combining multiple artificial neurons into layers and connecting them through weighted connections has facilitated the creation of powerful learning systems capable of extracting intricate patterns from vast amounts of data.
That's a great point. While the McCulloch-Pitts neuron model falls short in modeling the complexities of biological neurons, it nonetheless constitutes a stepping stone in the ongoing quest to understand and mimic the human brain through artificial intelligence.